In this video, we're going to take a careful look at how multiplication of larger numbers can be accomplished, and in particular, how by using the base 10 blocks in conjunction with the area model, it makes it possible to generate a record of action that lines up not only with the standard procedure that most of us grew up learning about, but also with the action on objects approach that we're advocating in terms of making a difference in our instruction. So let's imagine that in do-it-dang-it terms, there's my do-it-dang-it line, we are looking at the problem 15 times 15. And let's read that in terms of what the actions are. The actions would be, first we build a rectangle that's 15 units in one direction by 15 units in the other. And that's this section right here. That's the build the rectangle. So we're going to build that rectangle using physical objects, and we're going to make use of a few facts about the base 10 blocks to make our life a little bit easier. The first thing that we're going to do is we're going to notice that to build something that is 10 by 10 is simply our old friend, the hundreds flat. So looking at what we have from here to here, we have something that's 10 units. And by the same token, something that is from here to here is also 10 units. So that builds us a 10 by 10. Now, the rectangle that we're trying to build has to be 15 times 15. So if we've gone 10, then we really need to go 5 more to finish building that. And so if I put down this piece right here, that in essence takes that 10 by 10 grid and stretches it out now until it is 15 across. And you see we're building that 15 by a 10 by 10, and then we add 5 more units to that. And we can do the same thing here, so that to continue this down so that it'll have our full 15 by 15, we can put that piece in there. Now, it might be tempting to say that we're done right now, but you'll notice that this is not a rectangle. And in order for the area model for multiplication to work, it has to be a complete rectangle. So that means there's another little piece here that we need to fill. And we can guess how big it's going to be. It's going to be 5 in this direction and 5 in this direction. So I'm going to put that piece right up in there. There's my 5 by 5 piece. So we have now represented, using physical objects, our problem of 15 times 15. So just to reiterate here, to read this statement, we know that we're building a rectangle. That's what this symbol, in terms of action terms, is going to mean. We know that we represent something that's 15 in one direction by 15 in the other direction. And now we're going to do it, and in part of doing it, it's going to be figuring out just how many little pieces, there are in this thing. So we can make our life a little bit easier right now. We're going to split it up like this. All right. And so let's take a look at how big each of these 4 sections are and see if we can figure out where they're coming from. Count the largest section, anyway, it's going to be the easiest for us. And what we find here is that we find that it is 10 by 10, which is a hundreds flat. In counting up just how big these things are, the 10 by 10 is 100, and we know that because that's our hundreds flat. We're used to working with it. We've counted it many times. We've built visual fluency for it. And so now let's count each of our other sections. Well, what do we have here? This section is 5 in one direction and 10 in the other. And what we know about something that is 1 by 10 is it's simply a tens unit. And so how many tens units do we have? Well, we have 10, we have 20, we have 30, we have 40, we have 50. So this particular section of our area model represents 5 tens, and of course we can call that 50. And in looking at this section down here now, we also see that it's a 5 by 10. And so we'll go ahead and count it just for the sake of completeness. We would have 10, 20, 30, 40, and 50. So there's my 50. There's really only one little piece left to count, and that's this little piece in the corner. And so in looking at that, we can see that it's 5 by 1. So there's 5, and if we've learned how to skip count, we can go 5, 10, 15, 20, 25. If we're not comfortable with skip counting, we can count it using the models that we generated for small numbers. 1, 2, 3, 4, 5, 6, 7, 8, 10, 15, 20, 25. So at this point, what we have is we have each of these 4 areas, and to find out the total, we would smush them together. So I'm going to smush them back together here. That's physically, I guess, what we would be doing. We're putting all of those smaller areas and putting them back in together. So if we wanted to count them, we could make our life a little bit easier. Just for the sake of discussion here, we can take this group of 50 and we can take this group of 50, and you'll notice how nicely they stack right up. That gives us another 100, and then we have this 25 in the corner. So we have 100, we have 200, we have 225. So we have a large multiplication problem that can still be modeled using action on objects using the base 10 blocks. And I hope you can see we can do this for pretty much any number we would like. So 15 times 15 is 225. The record of action, if we were to draw this as a sketch and model it with a sketch, I can take what I've drawn here and I can just connect this up. And what you'll see is that we have 4 distinct sections. This is 10 times 10, so there's my 100. Here is my 5 times 10, there's my 50. Here is an additional 50, and here's that little 25 piece in the corner. So when we look at this, this is a slightly different way of recording this than our standard procedure, because typically what happens is we combine these two into one process and we combine these two. So you'll notice that 5 times 5 is 25. That's typically what you would see first. Then 5 times 10 is 50. Then 10 times 5 is 50. Then 10 times 10 is 100. Again, however, this is just an accident of notation. Just like Pa Kettle, when he was showing division like this, there are many different ways we can show multiplication. This particular approach has the benefit of tying in very, very nicely with the models that we're using, and in such a way that the kids can record their actions very quickly. Now, since we've got into this way of thinking where we can go from a sketch, I'm going to extend that just for a moment to show the power that a sketch-level representation can give us. The first thing we see is that in sketches I don't have to be overly accurate all the time, as long as I capture the major essence of what I'm going for. And I'm going to do something slightly different this time. I'm going to imagine that we have 20 plus 5 and 20 plus 5. And our task is going to be to think about just what our answer would be. Well, how would we record that? Well, this tells us to build a rectangle, 25 in one direction by 25 in the other direction. There's my build a rectangle sign. We do it. Okay, we've done it. Well, how can we tell what this represents? We have one group of 10 and another group of 10, one group of 10 and another group of 10. So this would give me a total of 4 hundreds flats. I would have a 50 here and a 50 here. I would have a 50 here and a 50 here. I would still have this little 25 in the corner. So I would say that 20 times 20 gives me 400. I would say that I have 100 here. I would say I have 100 here. I would say I have 25 in the corner for a total of 625. For this example, we've picked numbers to make our life a little bit easier, but there is no reason why we can't do a more general problem where perhaps something like 16 times 34. Let's think what that might look like. So in 16 times 34, as we think about it, we could either represent it with objects or with sketching, but in either case we're still going to get these 4 sections. We will have something that perhaps is 30 and 4 in one direction by 10 and 6 in the other direction. And when we keep track of how many hundreds flats that's going to give us, you see the 10 by 10 is where we get our hundreds flat. There we'll have our 4 tens. This will give us 6. Now this is a little bit interesting. So we'll have 60 here, 60 here, 60 here. Because remember, this is 10. So we'd have 6 10 rods, 6 10 rods, 6 10 rods. And then for the little piece in the corner, we have 24. So we would have 300. We would have 40. We would have 180 as we add these together. And we would have this little piece that's 24 in the corner. We add them up to get our answer. And if we are going to build the bridge to a more traditional representation, we combine steps. So all we have to do to go from here to the typical procedure that most parents and family are used to seeing is just combine these steps together. And in the process, you've now completed that so that all of these actions that can be done with physical objects or sketching lend themselves to a record of action where the record of action is quickly becoming the procedure, and within another lesson or two would be the procedure as we find more efficient ways to record our counting of the base 10 blocks. Clearly, any number can be represented with base 10 blocks in this fashion, so it's just a question of careful counting and organization where we keep track of our sketches.